Hello, everybody. These are the things that I want to accomplish today. I want to show you what Keyman Developer is and how to use that in a project, and actually build a very simple project. And if all goes well, we'll have a chance to actually test that interactively. If we have time, I'd like to show you some other options for building keyboards that are more sophisticated. And today's focus will be on desktop or laptop keyboards. Next time, we'll talk about mobile devices. And then if we are lucky, we will have a chance to actually see how the keyboard that we're going to build today actually can be installed and used on a Windows desktop. Keyman Developer, it's just at keyman.com/developer. It is an open source project. It also is a free application that anyone can load. It works on a Windows laptop or desktop, and it lets people build their own keyboards. It doesn't let people build all the options that they might like for applications on mobile devices, or swipe and other things. It lets people build keyboards for desktop, mobile, or laptop, and that mobile includes Android, iOS, and it also supports tablets with some pretty sophisticated applications. In addition, Keyman for mobile can provide text suggestions, basically a form of predictive text based upon a set of words that a person, developer, may have added. And that will be covered in our second section. Keyman Developer is really quite sophisticated, and there's lots of good stuff with it. I'd like to show you a little bit more about some of the tools that are available. Keyman Developer has a whole set of tutorials, and I'm going to give a very brief overview of this. Details are there. I use my favorite search engine to find Keyman Developer tutorials. As you can see, there are extensive instructions with this. We will cover a little bit of that. There are also many training videos, and I encourage you to look at these. And again, they cover an awful lot, and these are great resources for you. And Keyman Developer also has a user guide, which is more of a reference. There are two things to consider. Is the set of characters you're going to be using for your keyboard already standardized in Unicode? If it is, then that's great, because then you can build things that will work on desktops and not have to worry too much about whether the user will actually be able to see characters. But Keyman can also be used for writing systems that have not yet been standardized. This would include a writing system that's in the proposal state or the Unicode. We can build keyboards. We can use codes that are not standard in Keyman, and keyboards that are developed can be used on local laptops or desktops as long as a person has a font. But the ideal situation is when we're developing something for language and its writing system that are already part of the Unicode standard. For most of the languages of the world, A through Z, which are used in English, are not enough. And there are sources of ASCII characters or non-ASCII characters, which are very interesting and useful. You can always look up the name of a language, and Wikipedia has a great set of resources about all the different writing systems. Our friend Tex pointed this website out, which is called Upside Down Converter. Way of getting a character that is kind of fun. And we could perhaps get a few of these characters here. For example, there are characters which look like they are upside down. They're actually distinct Unicode characters. If I say convert the A and the little a and the capital A, I can get characters that are actually other Unicode characters that appear to be upside down. If you want a character and you know the name of the character, searching for that on the internet will often find what you want. If you know the script name, you know the language name, you know something about the character name, or you want to just searching for other kinds of characters. If it's on the internet, it is probably already a Unicode character and you can use it for developing a keyboard. Now, why am I so interested in the characters? Well, very simply, a keyboard is simply a device it's an application that lets you convert what you have in your mind in terms of characters into characters that are actually stored in a document or used another way on the computer. I'm bringing up the Keyman developer application, and I'll show you a little bit about how to develop a new project. One simply can start a new project by saying, I'd like to invent a new project. Let's develop a blank one. Give it a name. So this is inspired by Texas suggestion. Call it Upside. A little bit of information here, and I'm going to say that this will work on any platform where I'd like to develop this, and I need to give it a name of a language. So I'm just going to give this a language name, a language tag, English and Latin. ATN is the language tag. This will say, yes, this is a valid tag. Once that is there, then this is enough to get myself started on a new project. I click the keyboards tab and get myself a new keyboard. Already this is populated with something called upside.amn. Keyman, like a lot of applications, has specialized suffixes for many of its files that it creates. File-based application, files are stored in your local machine. And the process is that when you make these files globally, one takes another step to compile, which means take these things that you have been telling Keyman developer about and turn them into a program or a small file which can be sent to other people to execute. The development all done within in Keyman itself. The result of Keyman is a file which has another suffix, which we'll get to. So go to this new program or this new layout. And there are two tabs that appear when I do this. I go to this one, show you that Keyman actually says, we're going to base this upon default layout. The default layout is what you would see in a US QWERTY keyboard. And it works pretty well for other English. And the developer, this is Australian. The reason for this being the standard one. There are several options, but basically we're shown a layout of a standard keyboard. There is another option which is available, which I'll just mention briefly. If you want to have another kind of keyboard which has another key to the left of what we call Z here, between the shift and the Z. This is an option that will match some physical keyboards in other parts of the world, European keyboards, for example, or we can do without that. I'm going to do without that. What are we seeing here in Keyman Developer? Seeing positions. These characters here are not the actual characters which are produced by our result, but you can think about them as being a label for a key. So this key is actually label key for the character A. Now, if I go ahead and compile this, the default characters will be just what are in the QWERTY keyboard. I can easily change it. I can click this and I can say that I would like this output character instead of an A to be perhaps an X. Put that here, you notice that on that key it says X. It's also automatically filled in a character value, which says, that key is this Unicode value, which happens to be 0058. If I go to the code of my description here, you can see that it has added something. It is saying that a particular key cap or a particular key is defined. A, an underscore, and A in the square brackets is the way that Keyman says this is the position on the layout. It is not saying that character A will be produced by that position. It's actually saying add a key in that position and its output is the character X. I could add another one here manually in this code area, and I could say K underscore S right next to it. I would like that to be, let's make that to be Y. I type that in here and then go back to my design. I will see that the Y character is now the output here of that. And so on. One can continue producing the character.
I have a question. When you created the keyboard initially, you had to select whether you wanted this to work on any or specific operating systems. Is there ever a reason to exclude an operating system?
Not that I know.
Okay.
Not that I know. You might, I can imagine that someone would say, I only want this to be distributed to people who use Macintosh. But in general, I don't think there's a good reason to restrict.
So that would probably be some sort of non-technical reason potentially.
Most likely, yes.
Yeah. Okay.
Again, the Keyman documentation may help you understand more about this.
Okay, thank you.
It could be that certain keyboard layouts are only available on certain systems, and if you want to design a layout specific to a particular keyboard, that might be a reason for choosing one system and deselecting the others, because you know that that layout is only available on a certain device type.
That may be a good reason for that. Thank you. I also want to point out here, there's something else you may notice in the upper left corner where it says upside.kmn, which indicates that the file is not yet saved. If I hit Control S, it shows me that this file has been saved. And there's actually a directory where under upside, there's now a directory which will have that character. I go back to the Keyman project. So the process of creating a keyboard is very simply clicking on a key, and you notice that the key position is always noted down here in this area. And so I can keep track of where I actually am. If I want to set up the other layer here, I could set this key and the shift area. Suppose I wanted to be a little screwy and say that that's a lowercase x rather than a capital X. S key will be a lowercase y rather than uppercase. These things are easy to do because standard keyboards generally have the base layer, the shift layer, and most keyboards have control and also an alt layer. One can actually set up many layers within or for a standard desktop or laptop computer. Turns out that with the caps lock, that gives us at least 8 different combinations: base layer, shift or not, control or not, alt. And so that gives people a chance to create character sets or create keyboards that can do character sets that are bigger than the English language writing system supports. What kinds of characters can be put in here? Well, any kind of character can be put in here. If I want to go back to my base layer, Alt, back to the X. Suppose I want to put, instead of a character A here, I want to get something that's perhaps a little unusual. So I'm going to go back to my document where I have pre-populated it with some of the characters that I thought might be kind of fun. Here, for example, it's a list of characters in what's called the Fraser script. The script is not ASCII, but the characters look a lot like A through Z characters, but they are Swift. So I'm going to change the K key to have the upside down character And this is actually a Fraser script character. You can tell that it's not just A that's somehow been flipped by looking at the actual Unicode value. And for anything with Unicode, you can do a search and find something about the character. This happens to be that particular character in a language, in a writing system, which is used for the Lisu. So this is another way of adding a particular character. Or I might have a character that I need to use in from a native writing system. So I can copy this one and I can paste this one into, let's put it down here. This is variation on the L. It's an L with a bar, and again, it has a Unicode value. Show you that you can always find the characters or what the characters mean. I'm going to go to the search and a Unicode, Unicode and the value, and this will say, aha, Unicode Latin small letter L with its stroke. And most of these places are not necessarily run by the Unicode standard. It will also tell you things about the character, all the codes, lots of information about it. It will tell you where, as text told us about Unicode earlier, that it describes a number of properties of the character. Left to right character, it is has a number of other properties which can be examined. Some characters are alphabetic, some characters are punctuation, some characters are white space. And all of this can be found with many sources on it. And so this particular L with the stroke across it is used in a number of Native American languages. For example, Inupiaq, language of Northern Canada and Northern Alaska. So with this simple setup for my keyboard now, I can make sure I save it with Control S. I can do something fun now by saying compile. And so when I say compile, it produces an output and it says, aha, here's the source of it. It's creating one for Windows. It's creating for web, iPhone, etc. And by looking at this, I can see exactly where it was created and what files were produced. Note that it produces two kinds of files. One is called a KMX file, and one is called a .js file, a JSON, a JavaScript file. These are used, the KMX files are used on laptops and desktops, and the JavaScript files are used with mobile devices generally. Now, it's all well and good. Compilation working fine is great. I'd like to see, does this really work? What I can do now is go to the test layer, test my keyboard, brings up something, and it lets me actually touch the characters. Here I touch the A key. Notice what I see. This is kind of small. Can you see that there's an X there? Let's see, let's make the font bigger. Let's make a 20 size font. Now you can see that I typed the leftmost character in the middle row of my keyboard and I got an X. I type a space and I get a space. I type the S key and it gets a Y. I type a capital A and it gets me the lowercase a. I get the inverted K. What did I use? I typed the B character. So this testing lets me run this very easily and make sure that the keys that I touched are actually giving me the characters I want. I didn't define other keys. It turns out by default, those characters are there, A through Z, and all the other characters are actually filled out automatically. But this is my keyboard. works in this testing mode. I can also say, test the keyboard on the web. So I can test it actually on my local browser. I can pick one of these choices and say, open in a browser. It will come up with a place where I can type and actually see the character. Not telling what you want. Select the upside keyboard. Let's see if this does what I want. Now I select the upside keyboard and I type the A key, I type the S key, capital, I type the S key lowercase, I type the B key, and so on. And so this is demonstrating in a web browser that that the keys are working fine. Now you may wonder, why is this layout here that you're seeing empty? There's nothing there. Well, when you're touching on a keyboard that you automatically know, or that you know, and a keyboard that has the actual characters typed on the top of the keyboard, you don't physically need a cheat sheet with where the keys are. But in Keyman, it's very nice. The Keyman developer lets us do one more step. We can say, I'd like to build an on-screen keyboard, and I can fill it from the layout. And now what we have is the actual layout of the keys, basically as an image that can be displayed. Compile this. Again, it will compile for me, and I'm going to my other application. I refresh this. Oh, I don't even need to refresh it. Now my visible keyboard has the characters here on the base layer and a couple on the shift layer. So testing my device doesn't require, or testing my keyboard doesn't require me to install anything anywhere. It lets me do this very simply by running it from Keyman developer app and a web and a web browser. Now you may also note that there are some other options here. If I choose to run this as a Pixel 5, let's see what happens here. Here I have a default mobile layout, but you might wonder, I'm touching the A key and it looks like an A, but it prints out the S and it prints out the Y. What's going on there? What's going on there is that even though it's got a mobile output defined, I haven't defined the mobile keys, the key caps that are on there. And so that is something that we would do in an extra step. And test this as if it were an iPhone, and it will produce what's as expected, change what on those keycaps to make it work. And by default, it's a pretty simple set of layouts for mobile. There's the base layer, there's a shift layer, symbols, and numeric layer. So now, what happens if I want to take the next step? I want to actually develop this and package it for someone to use. And define something called, or I can go to the project and touch the packaging layer, and it has developed something called the KPS file. And the KPS file can be opened. Oh, here we go. KPS file actually will show you a number of things that are in a package that will be delivered to a person. It shows you the keyboards that have been added. In this particular case, it's showing that I've added one key, which is English Latin, and it has the name upside. I don't have any lexical models where I would add a set of word lists, basically a spreadsheet of word lists and frequency if I wanted to make predictive text for this. I can fill out all sorts of details about myself, about the keyboard, the author, a website that would refer to this, and I can add an image file if I want to for this. A lot of things, but the important point is that now I have a package here that is ready to be developed. package contains the sets of files which are needed for installing an any particular device. That's in say build. They compile a package. It happily builds something which is called a KMP file. And that KMP file is really, really important. That KMP file is the file that I would give to someone else to install on her laptop computer. That laptop or that file, when installed on a laptop computer in the Keyman application, will indeed run the keyboard that I have just defined. So let's see if we can do that. So I'm going to go to my file system, see if so I can go to Upside here, and I can see that what has been developed by Keyman is a set of files. These are files which are text information files, which I can edit within the Keyman developer, or I can edit with an external developer. Reference files include the KMN file, the KPX file, and other files which we don't have to worry about right at the moment. And go to the build directory, and you can see that the build directory has been updated minutes ago with several files: the job.js file, the KMP file, the KMX file, and the KVK file. Honestly, I don't know what all of them do. I do know that the KMP file is something that I can use to install on my. I'm going to try doing this. I'm going to click upside that KMN or KMP. What it should do is bring up the Keyman application. Now, may remember from our previous talk that the Keyman application is actually not for developing keyboards, but it is for applying a layout into your operating system. It basically says, map the keys that I type into their characters in the application. This is saying I want to, in Keyman, I want to install this particular thing called Upside. It installs it. It will ask, do you really want to let Keyman change what's on your computer? I say yes. It installs the keyboard. And then, if things go well, and they should, I should be able to see that this indeed has called the Keyman application, added this thing called Upside. It's generated. I could get all sorts of other information here if I had added that into my description in the Keyman developer. Now I should be able to go to applications such as typing simple text. The next step here is very specific to the operating system, and I'm not an expert at Windows, so I apologize. We'll make this particular little KMP file available if you're interested, and you can try it on your own machine. Let me just review the steps briefly. One builds a project, one builds a project, and you can see that the project now has two components. Keyman, the KMN file is used to create the layout and has equivalent in code, and the package file contains the information that includes the package file lets me compile this and build the output files that can be used on desktop or web. And then there's another step if one wants to go through here to for information for distribution. For example, there's a history file, and I can add text in here that describes this in great gory detail. There are other files here which can be edited that will come up and show information to the user when the user selects a particular file. And all of this can be done. This particular one is a HTML file. So this can be used with any browser, and this one wishes to describe the project, describe your work, point to other resources online about the language. There's all kinds of stuff that one can do here. I'd like to give an example of doing some other things with layout which are useful. One thing that very often people need to do is add diacritic marks. So for example, this particular character here is generally a single quote. It is not a actual combining mark. But suppose I wanted to change this on my keyboard and I wanted to change it to a combining mark. Now the combining mark for an acute accent happens to be this code. And when I type in 301, Unicode 301, you can see that it's changed the character here to be a very small thing that's kind of hard to see. I go over here and it points out that quote position on the keyboard, it is now producing a Unicode character that is within the quote marks there. It's kind of hard to see. Let me go ahead and rebuild this with that combining mark here. I want to test it again then. And I'm going to test the keyboard by typing my character, let's do an E, test keyboard. Check the upside keyboard. Now I type an E and I type that mark, and you can see that the quote mark or the accent now appears over the character. Why is that as opposed to the single quote? Well, it's a different character. E plus the 301 Unicode value give me a combined display of the base character E plus that quote. I can do that with any other character. For example, if I want to do an X with quote mark or a acute accent above it, simply do that, and the font is smart enough to do the combining in the right way. So this is one way that people can build composite characters are not represented individually with A quote, B quote, C quote, B quote. That would use up a whole character positions on the keyboard. To add a single combining character, it's very easy to have a particular key that will add. I'm going to add a another Unicode character, another combining mark here. To this one, I'm going to make this key be a combining character, a refill from layout, and you can see that now this key is a different kind of mark. Going to run over to the testing, compile again, I'm sorry. Compile again. It compiles happily. I reload this. Now here is the character, combining character that will take an existing character and produce the combining mark, the long mark over it. So I can take any character and add a combining mark. I can even add two combining marks to these. And this is a very nice way of making it so that it would work, for example, for African languages that use combining marks. Only limitation with this is that the font needs to be smart enough to combine these things in the proper